Build Science 101 is sponsored by Anderson Windows and Doors, Builder's First Source, Huber Engineered Woods, Polyguard, Sashco, and Durail.
All right, my friends, Building Science 101, Episode 2, Why Building Science Matters, Durability.
Wow, that's a loaded word in the building science world.
Durability.
You know, the minute you say durability, first thing that comes to mind, I know people out there literally making hundreds of thousands of dollars, millions if you want to include lawyers, on the fact that buildings fail.
That's right. That's right.
Right? It's that business is incredible.
And that's why this series is so important, Steve, is that if it doesn't last, it doesn't matter. I think I may have stole your thunder.
No, you're
probably
yeah.
Say that.
I say that all the time. It's like, we talked about control in the last one, and we want to gain control. We want to build an environment. But the most important thing about that environment, it's got to last.
That's right.
Right? It's we're going to get into a whole bunch of other aspects of building science and, comfort and health and energy efficiency and all of that. But I can build the best passive house in the world, have it 0+ energy. If I don't get the flashing details right,
That's right.
and water gets in and the building rots away, what have I done?
That's right.
I've done nothing.
And that doesn't necessarily mean that we need to build out of concrete. Now, we certainly do that in a lot of parts of the world. We don't in America. But analogy I love that I've heard Joe Stieber talk about is how long will your dining room table last if it's in your dining room, right? This table right here is a fake wood table. I suspect this is probably MDF underneath this veneer here. As long as this is in the studio, in theory, 100, 200, 300 years from now, this table will look just fine. If I take this table and put it outside and use it as a picnic table, how long will it last? A month? Maybe 6 months?
Yeah.
Even your best pressure-treated wood is only going to get maybe a decade or two outside before it starts to decay and look bad. So wood, these studs back here, an amazing building material. God gave us this imperfect material that is so fun to work with. I love the smell of sawdust, but if we make a table that's dry, that wood can last literally hundreds of years. I've been in Japanese buildings that were 1,000 years old. They were made from wood. But this durability is key. Now, where do we start on this?
So, again, bringing it back to durability, and it's, the number one killer of buildings, water, basically. But I always find it interesting that a lot of, as much as we understand water and durability to be an issue, I've never had a building inspector come out and say, hey, let's do a water management inspection.
That's right.
I want to make sure your flashing's right. Do you have kickoff flashings on the roof? And all these things you're going to learn later if you're not familiar with terms like kickoff flashings and stuff. But nobody ever really talks about how to provide solutions for water management. They immediately want to just talk about how much insulation do I have in the wall?
That's right.
Right? And if you're a young architect and a young builder and you want to get after it, the way you get after it is building something that's going to last and then bring all of the other things that provide the control that we spoke of
That's right.
into that building. But durability has to be your number one priority. If it isn't your number one priority, you're doing it wrong, flat out.
That's right. Everything else falls below in the order of importance.
Yeah, I always say, I'll use my other one before you steal this one. Durability is key. It's key to a successful building. I cannot have success without durability.
That's right.
I can build a building that churches in Scandinavia, been around for 1,000 years or 800 years, whatever, sitting in mud and in dirt.
Yep.
They're still here.
Yeah.
Why are they here? Because durability was the key. They have nice big overhangs. They have a lot of things that are instilling durability and the success of durability into their projects.
Yeah, for sure.
Right. So I thought I'd get a little architect-y on us. I broke out a simple sketch. This is actually Rhode Island's first passive house. I did it probably about 8 or 9 years ago. It's a hardline sketch, meaning that it's not freehand. It's actually using a triangle and a T-square. But I thought a building elevation, when you're talking about durability, is really important.
Yeah.
There's certainly a lot of aspects of what we're trying to do here. And because durability is key, you know, our good friend and mentor of everybody in building science, you know, Joe would say, hey, windows always leak.
That's right.
You know, beware of water. Water's the number one killer of buildings. And, you know, from that, what I've taken away is don't let water get on the building.
That's right.
Right? Keep the water away. If we're going to talk about durability, we want nice big overhangs here.
Yep.
So that the rain, when it comes down, it falls off of our building, away from our building.
That's right. And that's utilizing durability with physics rather than with chemistry, right? We can build a building with no overhangs and not make it leak, but we've got to get all the details perfect, and we've got to use the best building materials and, frankly, the most expensive building materials available, whereas this building that you designed relies on simple physics.
Yeah.
Simple gravity to bring the rain and shed it off the house.
And I know as architects, I see some architects, they love to challenge Mother Nature, right? They'll do parapet walls, nice flush. Hey, how can we get that knife-like edge between the window and my cladding? Well, I'm going to say that's okay, but my guess is, and I'm right probably 99% of the time, that architect doesn't put the same amount of energy into developing the detail from a building science perspective as he did or she did developing the aesthetic detail.
That's right.
And it's okay if you do those things, but building science has to play a major role, and it has to be equal or better.
That's right.
Because if you're going to take all that time to build a beautiful building and it rots away, I mean, my time at building science, we did a bunch of building investigations. As a young architect, I was literally appalled at going into buildings that were a year or two old, millions of dollars worth of construction, and the homeowners can't live in the building anymore.
Yeah, that's right. That happens. Unfortunately, that happens all the time.
It's crazy.
So let's take a step back, Steve, and talk to us about why those older buildings lasted.
So it's really interesting. The older buildings lasted because they were energy inefficient, right? I mean, think of an oven. We'd build a wood church somewhere out in the middle of the field. We'd put the big beams right down in the dirt. We'd build the church, and then we'd put a wood stove or a fire or fireplace inside this building.
Yep. And
pretty much bake the building dry.
That's right.
Right? We basically put the building, that lumber was in a perpetual kiln. Right?
That's a great way to say it. I like that.
We don't do that anymore.
Yeah.
Right? Because our building assemblies, I mean, this wall here is 12 inches thick. It's a double wall assembly, and it has a rain screen on the outside and all of these things that are working towards durability.
Yeah.
But the most important thing that you're suggesting is in an old building, if I had a wall, energy basically flowed through it.
Yep.
Right? In both ways. In the summertime, it would heat up also.
Yeah.
So even if it got rained on, that wood would still dry because there's not many places on earth where it rains more than the sun comes out.
Yeah, that's right.
So as long as I'm getting more sunshine than rain, then I don't have to worry about it. But the minute I start adding all kinds of different layers to this, right? We'll switch color. That energy is not making it
through the wall.
Up through the wall as easy.
Yeah. Either inside or outside.
Or outside. And that energy from the sun, is not really penetrating that wall. So in building science terms, we use a real high-tech term, the wall is less forgiving.
That's right.
Right?
Yeah.
So there's the older buildings were far more forgiving in that you simply bake them dry.
Yeah. Let me add one point to that too, Steve, that I've heard Joe Stiebrick talk about, and this is a nerdy term that I'm getting in here in episode 2, but Joe Stiebrick talks about hydric buffer capacity. You know, those 2x4s in the wall right there, if I were to soak that 2x4 in water, just like a tree has its roots into the ground, that water would rise up through the 2x4. And so that 2x4 actually has a pretty fair amount of hydric buffer capacity. You can pull water up and distribute it through the wood. On the other hand, a piece of MDF, a piece of drywall has very little hydric buffer capacity. If I put MDF in water, it's going to blow up and die on us, and it can't soak up very much either. Same with OSB or some advanced subfloors. They have a lot of glue, not a lot of ability to soak up water. So old houses, you know, that 1920s house that I remodeled a few years ago, it had real shiplap sheathing on the inside and on the outside. And back then, there was no insulation in the walls. They just had wallpaper right on top of, or basically right on top of the shiplap. And this wasn't, HGTV shiplap. This was real wood shiplap. So that house, even if it had leaky windows, like I've seen in a lot of houses on remodels, had the ability to soak up that water in that real wood, and then it could dry over time. Because, as Steve said, those houses were basically a modern kiln. I like the analogy of the hairdryer on the walls, right? When we turn on that heat in the wintertime, that hairdryer is drying out. It's baking those walls. And we had real lumber that was soaking it up. Now, I'm not saying we need to build our houses the exact same way anymore. What we need to do, though, is make sure that they're dry. Maybe we're going to get into this later, maybe that's making sure our windows are really installed with the best practices and they're flashed correctly, they have sill pans, they have head flashings. Maybe that starts with the design, though, like Steve's talking about, with some really good overhangs so those windows, as Steve said earlier, aren't challenged, that they don't even get water on the window to begin with. If we do that, then we don't have to use such perfect installs with perfect materials and precious and expensive things. We can make sure that those houses aren't getting wet to begin with. Another analogy I like is the big umbrella analogy. You know, if you think about all the houses built in North America prior to 1900, they all had a big golf umbrella on those houses. They all had 2, 3, 4 foot overhangs, like the buildings you mentioned in Switzerland. You got a big golf umbrella, kind of doesn't matter what you've got on for a raincoat. You're not really going to get wet. The only thing that might get wet is your shoes or maybe your bottom of your pant legs. Take away that golf umbrella and put a smaller umbrella up, and now all of a sudden, oh my gosh, we might get wet with the smallest amount of wind in that rain pour coming down. So it really starts with this durability.
Yeah, two things come to mind based on what you were just talking about. One, as our buildings get more sophisticated, we need a more sophisticated understanding.
Yep.
Right? We can't be an architect from 1956 that just draws a wall and says, oh, the builder, he'll handle that. Because in 1956, there was probably this wall or that wall to build, right?
That's right.
There wasn't many choices. As an architect now, there's all kinds of aspects of that wall that I have to deal with. The rain screen, drying, wetting, how vapor moves through. Just the whole building science, that idea of control. And we're going to get into the details, but at the highest level of understanding, we need to understand what the hell we're doing when we're putting a building together. And we need to be on the same page with our builders.
Yep.
And the interesting thing is, these days, clients are now part of that conversation.
That's right.
With videos like this, people going online and stuff, seeing Build Show Network videos and watching those.
That's right.
They're coming back and they're telling the builder, hey, I saw this rain screen system that Matt used on a house or Jake used. I want to use that on my house.
Yeah.
And so we're having those conversations, which are a good thing, but there's still, I could almost make a living out of helping builders that get drawings from other architects solve the problem.
That's right.
Because they message me, email me, Steve, can I pay you to have a 2-hour talk on this wall section? And we really need to get an understanding of what we're doing. And,
That's right.
And it's basically, Bill Belichick says it best, do your job.
Yeah.
If you're an architect, do your job. Design the house, but design the wall too.
Yeah, that's right.
Do it.
Let's talk for a minute about a phrase that you and I hear a lot out in the marketplace, which is houses.
Let me put my hip waders on because it's gonna flow.
It's gonna flow. Houses need to breathe. This is really something we need to talk about here in the durability phase. Houses need to breathe. What do you think about that?
Yeah. So 2 things come to mind there. One, if I had a client there and a builder says a house houses need to breathe, I'd look at the client and say, let me give you two scenarios. We could bring outside air in and we can condition it, right? We could take that conditioned air, we can run it through a filter or two, and then send it into the house.
Mm-hmm.
Or we can just let air come in through all the nooks and crannies, especially the ones that are at the bottom of the wall, right? Where you have that bottom plate and you have carpet on the inside,
Mm-hmm.
and it comes in. Guess where you can't vacuum? Yeah, that little inside corner.
Yep.
Yeah, that's going to become the filter of that outside air. So, Mr. or Mrs. Client, which scenario do you prefer, right? End of story there. If you still don't believe me on houses need to breathe, if you're so confident as a builder, as a client, as an architect that buildings need to breathe, then why don't you tell your clients to leave their windows open an inch all year? So at least then, if they need to breathe, let's get aggressive about it.
That's right.
Let's open the window and let's let them breathe.
Yeah, that's so funny. You would never do that.
You would never do that. So can we, every time we have this topic, I say, can we please put the bed? No, we won't. 6 months from now, I'll be at a conference and someone says, Steve, don't you think buildings need to breathe?
You know what's interesting about that though, Steve, is I think that there is a little bit of building science knowledge when someone says that, just not complete knowledge. And that's why this series is so important. You know, as we talked about, your example of the church being built in a field that has an oven in the center, that's baking the walls. Those buildings did breathe, right? And those buildings needed to breathe because they needed some airflow through the walls. They needed that heat to go through the walls. Today, we have modern building codes, no matter where you're building and where you're watching this, whether you're in Canada or America or Europe or wherever, we have building codes. We can't just build, like we did in the 1700s. Or maybe a very few of you could, but not many could. So if we are building modern buildings with modern building codes, we can't let houses breathe because ultimately it's a durability issue. You mentioned that bottom plate and air leaking underneath that bottom plate. Where I build in Austin, Texas, today it's 65% humidity outside. And when I got to the studio this morning, it was already 80 degrees. So if that air is leaking in that's 80 degrees and 65% relative humidity, I'd be willing to bet that the dew point, meaning the point that water forms, think about your cup on the table that has ice in it, it's going to have condensation on the outside of that glass. That condensation is going to run down and form a puddle on this table. The same thing can happen inside the walls of our houses under various conditions, especially the condition where air is leaking through that wall assembly. And if that condensation occurs on the back of sheetrock, for instance, like I've seen a lot in remodels around Austin, Texas, that's where we get mold growth. That's where we start getting into unhealthy situations for our clients. And ultimately, that can even lead to long-term durability and even building failures, let alone indoor air quality issues.
So, you mentioned dew point, right? And then you went into condensation. Well, do you understand what another word for condensation is? Dew, right? If you live in New England and you walk across the grass in the summertime, if you played golf at 5 a.m., guess what? Your golf shoes get soaking wet. Why? Because of condensation. The moisture in the air is condensing on that cold surface of the grass, and you're reaching dew,
yep,
right?
That's right.
Which brings up a really good point. You bring up water, right? I've heard Jake, I won't steal his thunder because Jake's a builder friend that we do work with. He's a contributor. Yes, Jake Bruin, contributor on the Build Show here. When he became a builder, he tells the story, he went and looked at, hey, what's the number one killer builder, number one litigation issue? It's water.
Yeah, I've heard the figure 80%.
Yeah.
Construction defect litigation is water.
And I remember a story when I was talking to a production builder, if you had a slider and a 2-story wall, and this particular production builder, that was their number one most expensive callback. And it wasn't because of the flashing. The guy would tell me, his name was Scott. Scott would say, listen, I have to replace the door. It means I got to pull the door out. I got to fix it. But guess what? When that water came in, it ruined the floor.
Mm-hmm.
It's a hardwood floor throughout the whole first floor. I just can't sand the first 3 feet. I got to knock down the whole floor in the room.
Yep.
Right? So that one little leak, now you're sanding the whole damn floor. How do you think a client feels? If you're a builder and a client has to do that in the first year or two, What does that say about you as a builder?
That's right.
Right? And I'll write it here so we have record of it. But water, number one killer. If in this video you take one thing away, you need to walk away with saying, I need to ask the question, where does the water go?
Yeah.
Everything I do, when I look at an elevation, I should be asking, where does the water go?
That's right.
Right? When I look at the way the ground is getting graded, where does the water go? When I'm in the basement, where does the water go that's on the other side of that foundation wall?
Yeah.
Right? If I'm in a house here and I have an entrance door here, makes sense to put some kind of porch roof on there, right? Where does the water go? Well, it doesn't go over my door, it doesn't challenge the door, and it doesn't challenge me when I'm standing there at the door.
That's
when I install a window, you brought it up earlier, windows in 2-story walls versus windows under overhangs.
Yep.
The one under the overhang, I don't have to worry about that much.
Yeah.
But this one here, I have to worry about all of that water coming down on that window.
Because that umbrella for the house is way up high on that case.
Where does the water go?
Yep.
And I'll finish with the sentence of, Mother Nature always wins.
Yeah.
Right? Where does the water go? You might win a battle or two. And if you're a builder that's set out to make your 1-year warranty and all of that, God bless you. I talked with probably what I would consider the best builder in Boston, and he gives a 5-year warranty on his projects. And I was like, wow, everybody else gives a year. He goes, Steve, the reality is I'm building multi-million-dollar homes. I own that house as long as it exists.
That's right.
So I might as well get the marketing effort out of what I'm doing. So I tell people I'll give them a 5-year warranty because you know what? In 6 years, I'm going to go back and fix a problem in that house for those people.
Yep.
Right? But there aren't going to be any problems because he asks, where does the water go? When it comes to Mother Nature, you might win a battle. You might win 2 battles. Mother Nature never quits.
Yep.
She is the greatest adversary the building industry has.
Yeah.
She doesn't quit. She's pounding every minute of every day.
100%. This episode of Build Science 101 brought to you by our friends at Huber Engineered Woods. This is the maker of Advantech subfloor and the zip system sheathing that you see so much on our houses under construction. These guys are a long-time supporter and friend of the Build Show. Steve, how long have you been using their products?
I've been using Zip Wall ever since it came out, actually. I remember the first time it came out, I was introduced to it. Questioning how good this system could be because it was new integrated weather resistive barrier, right? Trying to get rid of house wrap. And I was doing my first passive house at the time.
Wow.
So we built a full scale mock-up of Zip and we zipped over all of the openings except the one we did the blower door, 0.32.
Holy cow. You're like, oh, we're on to something here.
We're on to something here. The system works. The system works.
My intro to Huber Engineered Woods was Advantech. I'd built my very first custom home in Austin, Texas, 2005, and it rained during construction. And all my plywood seams, even though I had 1.125" plywood, the heavy, good stuff, expensive stuff, all my seams buckled on me. It was my first house I built as a custom builder, and I didn't factor in that extra, I forget what it was, like $800,000 to come in and sand all the seams on a 4,000 square foot house before the hardwoods got put down. It was a big deal. It busted a budget for me big time. So I said, all right, there's got to be a better product. I did some research. I came across 1.125" Advantech. They also make it in 3/4, of course. And you know what? Once I used it, that house got rained on. I had no sanding, no buckling, no change. I was sold. I've used it ever since.
We actually did a slabless basement system where we did 2 layers of Advantech. The house got flooded, 6 inches of standing water. We pumped the water out, dried the Advantech. It was like brand new.
Holy cow, that's an amazing product. Now here's my intro to the zip system sheathing. When it first came out, 15 plus years ago or so now, I was a bit of a detractor. I thought, how could we be dependent on tape for a system? But you know what? I saw what they were doing at the J.J. Pickle Research Center with the University of Texas Construction Durability Lab. It's like a mile from my office here. And I saw samples of all the different house wrap products on these racks facing the Texas sun, weathering for years at a time. And when I first saw that, it had been out for a couple of years in the sun, and I couldn't believe the damage that all the other systems had, whereas the Zip system looked almost brand new.
Yeah, I have 2 pieces when we did that house. We taped them together. They put them on my wood pile. They've been frozen, rained on, snowed on, sun beating down on them. We're going into our 14th year. The tape is like brand new.
Holy cow. Great company, great products, and lastly, I want to mention great tech service. If you need any help from these guys, they've got an amazing team that can help you with your technical questions. You can learn more about these guys at huberwood.com, or of course, the Gram's a great place too. They have a great social feed at Huberwood. Thanks again for sponsoring, Huber. What a great episode, guys. Durability is that next step on the ladder. Once we've got control and we think about our condition space, like we talked about in episode 1, then the next rung on the ladder is durability. Guys, stay tuned for episode 3, Building Science 101. We'll see you next time on The Build Show.